This video is a project breakdown / tutorial where I walk you through how to achieve this watercolor effect. The artwork was inspired by the incredible character design by Lakey. I highly recommend checking out her Instagram. I've also included her profile in the video description, so be sure to give her a follow. But to keep things simple in this video, I've set up a smaller scene that contains all the techniques from the original animation. I break down everything step by step so you can follow along. I've also uploaded the project file and some modifiers for free on my Ko-fi page, so feel free to grab them if you'd like and experiment with the effect by yourself. In a nutshell, the effect is built on 3 simple main components. A Toonshader that reacts to light, line art created using geometry nodes and grease pencil, and a real-time compositor setup that ties everything nicely together. Some parts are a bit hacky though, since I challenged myself that everything works in real time in the compositor. I note the points in the video, but I mean, this is part of the fun, right? So let's dive in and create a watercolor effect. Now, before we start, I'm using Blender 4.3 because we're going to use the real-time compositor later in the video. Make sure that in the render properties, you've set Eevee as your render engine, and in the color management, the view transform is set to standard. Also, make sure that you have the Node Wrangler add-on enabled. At the heart of most stylized shaders, there's a basic Toonshader. To create one, grab something to shade. I will use this little skull model here, and I will rotate it around so we can see the shader a bit better later on. Up into render view by pressing Z on the keyboard. Next, delete the principal BSDF node and replace it with a basic diffuse shader. Feed the output into a shader to RGB node, and then into a color ramp, with the mode set to constant. If you have a sun lamp in the scene, you can now control the light and shadow parts with these handles. Add a mix color node after the color ramp, and plug the output of the color ramp into the factor of the mix color node. Now you can select a shadow color and a light color. I'm going for a light blue for the shadows and a white for the highlights. The cool thing is that it reacts dynamically to our sun lamp in the scene. Now this is just a super basic setup. You can leave it at this, or you can make it as complex as you want. If you look at some watercolor art, you can see that the edges are rarely perfect. So as a next step, we're gonna break these perfect edges up a bit. A lot of the heavy lifting actually will happen in the compositing later on. To create more natural looking edges, let's use a simple noise texture. If you press Ctrl T on the keyboard with the noise texture selected, we get a texture coordinate node and a mapping node. I quickly swap the vector input to object and Ctrl Shift click on the node to get a quick preview. If we add a mix node in between the shader to RGB node and the color ramp node and feed the color output of the noise node into the B input, we can now control the amount of the edge breakup with the factor slider. Next, I'd like to add some color variation to my shadow color. There are many ways to do this. One neat trick is to use a Voronoi texture to get a more painterly look. ComfyMock actually has a great tutorial about this topic, and they go into much more detail. I'll link the video down in the description, but here are the basics. First, let's make some room for some more nodes and add a Voronoi texture. I'll connect the vector output of our mapping node with the vector input of the Voronoi texture and set the feature output to smooth F1. Ctrl Shift click on the Voronoi texture again to get a quick preview. Make sure you select the color output. The node gives us these nice spots in random sizes. Connect the color output of the previous noise texture with the smoothness input of the Voronoi texture. Add a color ramp node in between. With the handle position and the color, we can actually control how painterly the spots are. To use this in our shadow colors, we can feed this through a color ramp into a mix node. Set the mix node to overlay. You can use the factor slider of the mix color node to control how strong the color variation is. And to control the size, use the scale factor of the Voronoi texture. Yeah, that's basically it. I'll quickly add some groups for my future me in order that I'll understand what I was doing, hopefully. To do this, just frame the nodes accountable for the Toonshader and rename the frame by pressing F2 on the keyboard with Toonshader. And do the same thing for the color variation. So this is our finished setup. Now let's move on to the line art. There are several ways to create line art in Blender. You could use the line art modifier with grease pencil. However, the line art modifier is slow, and for this project I opted for a different method that works in real time. The line art consists of two main parts: an inverted hole that creates the outline of the shape, and grease pencil lines that add additional details. Let's start with the inverted hole first. The inverted hole method is one of the easiest ways to create an outline in Blender. The basic principle is that you solidify your object and invert the normals on the outer part. This way you have a nice outline around your object. I wrote an article about this a while back. I'll link it in the description. Here I'd like to show a different method with geometry nodes. This way we can create our own outline modifier, tailored to our project needs. You can download the modifier for free on my Ko-fi page, if you want to skip the next part, where we build one from scratch. You'll find the link in the description. Now, let's pick up where we left off. I created these black areas by selecting the corresponding faces in edit mode and assigning a basic black material to them. To create the outline in geometry nodes, open the geometry nodes editor up here and create a new geometry nodes modifier on the object. Click new and give it a name. To start things off, I add an extrude mesh node, and I'll make sure I uncheck the individual extrusion checkbox here. The offset scale slider lets us define how strong the extrusion is. Add a flip faces node after the extrude mesh node. Add a join geometry node after that and connect the geometry input with the flip faces output. Add a set material node after the flip faces. The material socket lets us choose a material for the outline. So let's create one. I quickly add a dummy cube up here. Select the cube and change the editor back to the shader editor. Here, create a material and name it outline. Let me skip ahead through the material creation process. I'll show you a screenshot at the end. Basically, I mix an emission shader with a transparent shader twice, using the geometry backfacing and its camera ray as factors. This setup ensures that our outline appears only where needed, in both Eevee and cycles. Here's the crucial step for later. Add an AOV output node and connect the shader's result through a shader to RGB node. Name the AOV output to outline, then, and this is important, go to the View Layers panel, scroll all the way to the bottom and create a new shader AOV. Make sure to use the exact same name as you used in the node. Here's the complete shader setup if you'd like to copy it. Back in the Geometry Nodes editor, I can now select the newly created outline material. Now with the first part done, I reframe these nodes and rename them with outline. Let's make some room again and focus on the shape of the outline. It looks too perfect and too boring. To change that, add a set position node and our good friend, the noise texture node. If we connect the color output to the offset, we successfully transformed our outline to a neat haircut. To change that back, we need to add a vector math node set to subtract and set the values to 0.5. This will push our displacement back towards the center. I lower the scale of the noise texture to something like 2. To control the strength of the effect, I'll add a vector math node set to multiply after the subtract node. Now let's frame these nodes up and name the group to something like displacement. To see things a bit better, you can change the label size in the end panel. Now I'd like to make the modifier a bit more user-friendly. I don't want to go every time into the Geometry Nodes editor to tweak things. The cool thing is that we can add the important values that we want to control to the modifier. First, I'd like to control the thickness of the outline. I'll add a math node set to divide between the output and the offset scale. I'll increase the value to something like 1000. In the end panel in the group section, I will rename the socket to thickness and change the default value to something like 5.5 and the minimum value to 0. Now we have much finer control over the effect. To control the noise scale, I will do the same thing. I'll duplicate the group input node and connect it with the scale socket and change the name to noise scale. To control the strength, I'll duplicate the input node again and connect it with the vector input of the multiply node. I'll change the type from vector to float, so I don't have to fiddle with 3 values at once. I'll set the default here and in the modifier to 0.02 and rename the socket to strength. Now we can control the strength in the modifier panel. For finer control, I'll do the same trick as before and add a math node set to divide between these two nodes. I'll duplicate it one last time and connect it to the material socket. As a last step, what I usually do is adding some sort of a switch to quickly toggle the outline on and off. Add a switch node and another input node and connect it to the switch input. Swap the inputs from false to true and connect the initial geometry input from all the way back here to the false input. Rename the switch and tidy everything up as we did before. Great, our modifier is finished. Now we can shift select all the objects we want to add the modifier to. Just make sure that the skull is selected last. Then we can copy the modifier to all selected objects. Now we have precise control over each outline and can adjust them exactly how we want. Moving on to the grease pencil line art. To start drawing with grease pencil, add a grease pencil stroke. Hop into edit mode with Ctrl Tab and delete all the points. Now before we start drawing, I usually set the stroke placement here to surface and the strength to 1. This way we have a nice black stroke that sticks to the surface. By the way, I'd recommend you use a drawing tablet. Any tablet will do, it just lets you control the thickness of the stroke with the pen pressure, which is super convenient. F on the keyboard lets you change the thickness of the brush, but don't worry, you can change the stroke thickness in edit mode by selecting points and scaling them by pressing Alt S. If you have proportional editing enabled, you get smooth fall-offs. That's all for the setup. Now I'll fast forward and draw all the details I want. The style really depends on what you're going for, but for me, less is often more. And don't try to be perfect here. Imperfections will give your work some life. Now, with that done, I'd like to convert the grease pencil to a mesh with geometry nodes. Do the same thing as we did before. Create a new geometry nodes modifier and hop into the GeoNodes editor. Here we're going to use a grease pencil to curves node. Make sure you have layers as instances unchecked. Next we will add a curve to mesh node with a curve circle as the profile curve. The radius lets us control the thickness of our mesh strokes. Now let's add a set material node, create again a dummy cube and create a super simple emission material. Just make sure you add an AUV output node and name it the same way as we did before. I went with outline. Back in the geometry nodes editor, we can select our grease pencil line art material. I also add a switch node and a join geometry node at the end. Connect them as you see on screen. Now the switch lets us enable the actual grease pencil object underneath, which lets us select individual points in edit mode. Now you don't just have to copy what I do. You can build your very own thing here. For example, for some more wobbliness, you could add the same displacement setup as we did before. But here, I'll go with the simple setup. With this, our line art is done. Before we move to the next part, I'd like to quickly show you how to create line art using the line art modifier with grease pencil I mentioned before. Again, in this project I didn't use this method, but it's a great technique nonetheless. To create line art using the line art modifier, select the grease pencil object and add a line art modifier. Important note though, you need a camera in the scene that it will show up. Select a collection containing your objects, a layer and a material. To make the lines less perfect, we can add a noise modifier after the line art modifier. Play around with the values until you get a decent result. The important values here are position, strength and noise scale. A great feature of this modifier is that enabling the random checkbox animates the displacement, giving everything a hand-drawn appearance during animation playback. When working with other modifiers like I'm doing here, check the order of your modifier stack if things start looking weird. Remember that modifiers are computed from top to bottom. With this also done, we can move on to compositing, where we tie everything together. Go into your view layer properties and enable the combined and Z pass if you're using unmodified grease pencil, and all the way at the bottom enable the material cryptomatte pass. Then open the compositor up here and check use nodes. If nothing's showing up, add a render layer node and a composite node. Now I promised some real-time compositing at the beginning of this tutorial. By enabling the compositor in the viewport shading options, any changes we make in the compositor will display in real time within the viewport. Now to create our watercolor filter, add a filter node and change the filter type to diamond sharpen. Add a glare node and change it to fog glow, quality to high, and the size to a lower value. Next, add the most important node of the effect, the Kuwahara filter. Change the mode from classic to anisotropic and increase the uniformity, sharpness and eccentricity to a higher value, because we're going to mix this with a second Kuwahara filter and use here a higher uniformity and size and lower sharpness and eccentricity. Lower the value of the mix node to something like 50-50. After the first Kuwahara, add a filter set to diamond sharpened with a value of 0.5. Now I'd like to isolate the outlines from the colors. But quick disclaimer here, the way I do this is a bit hacky. In a production environment, I would use Blender's view layers for this. But since they're not yet supported in the real-time compositor, I'll do it the hacky way. Add a cryptomatte node at the beginning of the node tree, change the view layer to material and type in the material names you chose in the geonode setup of the outline and the grease pencil line art. This gives us a mask for all the dark parts of the image. Feed the matte output through an invert color node and into an alpha socket of a set alpha node. Connect the initial image output to the image input of the set alpha socket. If we now add an inpaint node after that, we can fill in the line art of our image. Frame all the nodes and name them watercolor effect. Now I'd like to composite our line art on top of the blurry watercolor image. To do that, add a new render layers node and feed our custom AUV output we created at the beginning through an alpha over node. Then add an invert color node and mix that as the factor with our watercolor image. The color socket now lets us choose an outline color. If you want the underlying color to shine a bit through the line art, add a hue saturation node and feed it through a color ramp and mix it with the previous node and set the mode to color. If we select now a color in our color ramp, we have a slightly blue outline. Now tidy everything up and let's add the final thing, a paper texture. Of course, you can scan your own paper textures, or you can go to texturelabs.org. TextureLabs is an online resource for free original textures. These elements are created by TextureLabs and are free to use even in your commercial work. Brady Erickson has put a lot of love into these resources. He also has a YouTube channel, so go there and show him some love. I'll link it in the description. For this project I downloaded this paper 304 texture. To add this paper texture to our image, we can simply mix it with our image and set the mode to overlay. This will give us a nice paper-like color variation to our image. Now, to make the colors a bit more natural, we can mix it with a medium gray. I'll use a color ramp for this. To add the texture also to the background, I'll mix it again through a color ramp node and set the mode to multiply this time. Lower the factor a bit so it isn't as strong, so everything ties nicely together. You can also add an image sequence of paper textures here. For this, add an image sequence node and select a sequence on your machine. I'm sure YouTube compression will kill this, so I will just use the still image for now. But in certain cases, this can add a lot to your animation. Now tidy everything up for a third time, and we're done. Now again, don't just copy what I do. Your project probably has different needs than mine. Experiment a bit, especially with the Kuwahara nodes. If you add, for example, a blur node after the second one, you get a cool color bleed effect. As a little bonus, I'd like to show you how I created this runny watercolor effect. I used it in both projects, as a backdrop here and as a mask to fade out the brick wall in the board animation. The cool thing is that it's controllable and animatable. Together with the compositing we did before, it creates a convincing watercolor effect. The basis for this effect is a simple geometry node setup that utilizes the geometry proximity node. We can use the approximate distance between two objects and use this as an attribute in the shader. Let me first hide the skull so we can focus on the backdrop a little bit better. Add a plane and subdivide it quite a bunch. I'll go with about 60 subdivision levels. Then add a controller object. A simple sphere will do the job. Disable the shadow ray visibility of both objects in the object data properties. Rename the controller and hop into the geometry nodes editor. Create a new setup and drag and drop the sphere object from the outliner into the geometry nodes editor. Make sure the object info node is set to relative. Add a geometry proximity node and feed it through a map range node. The values don't really matter here at this point, you will tweak these anyway later on, depending on your project. When in doubt, leave them at default. Then feed the result into a free output socket of the group output node. Rename it to distance in the group properties and in the output properties of the modifier. Now it's time to build the shader. On the mesh plane, create a new shader and add a gradient node. Press Ctrl T on the select node and change the location to -0.5. This will center the gradient. Add a color ramp node and bring the handles a bit inwards. Then add a noise texture node and increase the value. Mix the noise node with the mapping node and set the mode to screen. Lower the factor and play around with the values until you get a result you like. At the end of the node tree, mix a transparent BSDF with an emission shader and use the color ramp output as a factor. In the material settings, change the render method to blended for a noise-free result. Now I'll incorporate the proximity mask. For this, add an attribute node and type in distance. Add a noise node and mix these two together. Change the mode to screen and feed it into a mapping node with the values set to -0.5. Add a mix node and set it to darken. After that, add a math node and set it to greater than with a value of about 0.4. Use this as a factor and mix the result of the previous mix shader node with a transparent shader. To hide the controller in the viewport, you can set the display type as bounce and disable the camera in ray visibility. This is just the start. In the finished file, which you can download for free on my Ko-fi page, I added a secondary color and animated some of the factor values of the mix nodes to get a runny watercolor effect. And that wraps up the project breakdown. I hope this breakdown gave you a good understanding of how the watercolor effect works and how you can experiment with it in your own projects. Let me know in the comments if you have any questions or if there's anything specific you'd like to see covered in a future video. Thanks for watching, and I'll see you in the next one.